So once again, a very good morning to all of you. In the last class, we have discussed about draft tube. That what is a draft tube? What are the advantages of draft tube? How a draft tube works? What are the different types of draft tube? Or if you remove the draft tube from a system, then how that system will behave? Or what are the flaws or faults that can come in a system if you don't install draft tube, so all these things we have discussed in the last class. So if you have not gone through that video, you can see that lecture. It is very much in this, it must be very much there in this group itself. Okay, so what are we going to study today? So today basically I'll be deriving one derivation, not deriving, I'll be stepwise we'll reach to a point and we'll try to find out that what will be the pressure at the inlet of draft tube. Okay, as the water enters into the draft tube, suppose if the water enters here, okay, then at this point what will be your pressure head? So this is what we are trying to calculate. In this process we will also see that why the installation of draft tube improves the efficiency. That we'll also find out in this lecture. Okay, so first of all, let's draw the image. Let's draw a diagram of a draft tube. So this is your turbine casing. Okay, then draft tube, as we have learned in our last class, it's a continuous increasing cross-sectional area. Okay, gradually increasing cross-sectional area. Okay, so this is the end of your draft tube. Okay, and the draft tube is always submerged in water. Okay, it is never above the water, it is always submerged into the water, and this is known as your tail race. Okay, I hope you all know this. Okay, so let this section be, suppose let this be section 2 and this is your section 3. Okay, so let this height be y2. So y2 means the point at which the water is entering into the draft tube and the bottom of the reservoir. So this distance is called y2. Let this distance be y. Okay, so y is what? Y is the distance of the bottom of the draft tube from the tail race. So y is the distance of the distance from the bottom of the draft tube to the tail race. So this is called y. Okay, so this is also something that we will write later on. So this will be your inlet of the draft tube. Okay, and here you can say it will be your outlet. Okay, and one more thing, when the water enters at this point, here the velocity is v2 and here the velocity is v3. Okay, in this direction your water is moving. And last but very important thing, above the tail race at this point the pressure will be PA. Okay, PA. So tail race is at the pressure PA and PA is nothing but your atmospheric pressure. Okay, so this is the diagram and we will start from here. Okay, so you have to remember the diagram. So this is your turbine casing. After that you will make a draft tube. Okay, so this will be submerged in your reservoir. This will be your reservoir. This point will be your tail race. Y2 is this distance, y is this distance, and this is your third cross section number 3. This is your cross section number 2. Okay, so now let's start our calculation. Now if at this point you apply the Bernoulli's theorem, we have to apply Bernoulli's theorem at this point and at this point. Okay, so first let's write applying Bernoulli's equation at section 2 and 3. So when you apply Bernoulli's equation at section 2, how, see, what is Bernoulli's equation? You should remember these things. P upon rho g, or you can write P upon W plus V square upon 2g plus Z is equal to constant or whatever. So this is something that you always need to remember. Now here you can write at section 2 P2 upon W means rho g, plus V2 square upon 2g plus Y2. Here it will be Y2. Because see, one more thing I forgot to tell you, this is your datum. This is your datum. So with datum the distance is y2, so this will be your y2. Okay, now this is clear. Similarly you apply the concept here, Bernoulli's equation at section 3. Here it will be P3 by W plus V3 square by 2G plus 0. Now why it is 0? Because here the distance is same. Datum and the point, the distance between this point and the datum is 0. Therefore it will be 0. The potential head will be 0. Okay. Plus HF. Now this is important. What is HF? HF will be all the losses that happens while the water is traveling from this point to this point. So इस point तक जो भी आपका water travel कर रहा है, whatever the losses that are happening, that you will be accounting here. So that will be your HF. Okay. Now, so you can write this equation as P2 upon W is equal to P3 upon W plus V3 square upon 2G plus HF minus V2 square upon 2G minus Y2. Simply you are putting out these terms or keeping this term, bringing these terms on your right hand side. And this can be written as P3 upon W minus Y2 minus V3 square minus V2 square upon 2G minus HF. Okay, so you are simply P3 upon W minus Y2 and then minus plus HF. So plus HF minus V3 square by 2G minus this will be V2. This will be V2, this will be V3. So minus plus minus. So minus V2 square upon 2G minus V2 square upon 2G minus it will be plus. So plus V3 square by 2G plus V3 square by 2G. So everything is correct. Okay. So now this is clear to you. Okay. So now let me proceed ahead. So next we can proceed. I think because I don't want this to disappear so that you can relate whatever we are doing. Okay, so okay, next we can write it here. I'll try to write it here. So now the next thing is that P3 upon W is equal to PA upon W plus Y. Okay, so P3 upon W at this pressure, the head will be what? The head will be this head plus this head. Obvious सी बात है, आपका पानी जब यहां से यहां आ रहा है तो यहां पे टोटल हेड क्या होगा? इतने के बराबर. एंड दिस कैन बी ब्रोकन इनटू दिस हेड प्लस दिस हेड. सो दिस हेड इज y and PA upon W, since the pressure is PA over here, so this will be total PA upon W. The total head will be PA upon W. So PA upon W plus Y will form P3 upon W. Okay, so now I hope this is clear to you. So now you just substitute this. So you can write P2 upon W is equal to PA upon W plus Y. You are simply substituting this. Then you can write PA upon W plus Y, then minus Y2 minus V3 square, V2 square minus V3 square upon 2G plus HF. Same thing, you are just substituting P3 upon W to PA upon W plus Y. So this you can write it as PA upon W plus Y minus Y2 minus V2 square minus V3 square upon 2G minus HF. Sorry, it will be minus HF. Okay, now Y2 minus Y. So this so although this is Y minus Y2 minus Y will become what? Y2 minus Y. It means this entity. Okay, yeah, now I think it is visible. Y2 minus Y is this entity. So this entity is called HS, which is called suction head of the draft tube. Okay, so the total distance, the total vertical distance minus this distance is your suction head, and this is denoted by HS. So this will be denoted by HS. Okay, and second thing, V2 square minus V3 square upon 2G, this entity is called dynamic head. Okay, so this equation now can be written as, I'll try to write it here only. Now this equation can be written as P2 upon 2G is equal to PA upon W minus HS. See, HS I cannot put it here because y2 minus y, so it will become minus HS minus, then you can simply write it V2 square minus V3 square upon 2G minus HF. Okay, so now this is your final equation. Now here you have to observe one thing. P2 upon 2G, P2 upon 2G is your head at this point. Got it? P2 upon 2G, see 2 is this section P2, so P2 upon 2G is the head at this point, and therefore this head is equal to PA upon W minus something minus something minus something. I hope you are getting, I hope you are, आप वहीं पहुंचे जहां मैं पहुंचाना चाह रहा हूं. So P2 upon W, the head at this point is equal to atmospheric head minus something minus something. Yani this value will be lesser than atmospheric head. So the pressure head at this point will always be less than atmospheric head. You have to remember this. The pressure at this point will be less than atmospheric head, and this is the reason why in every book it is written that draft tube produces negative head. This is the answer. If in the book you see anywhere that they are writing draft tube produces a negative head, what does that means? Obviously the value is not in negative, it is in positive only, but this head is less than the atmospheric head, and since atmospheric head is the reference head and it is less than the reference head, therefore it is called negative head. So आज के बाद यदि आप किसी बुक में पढ़ें कि draft tube produces negative head, so you should always remember it is negative with respect to atmospheric head, it is negative with respect to the reference head, the value is in positive only. Fine. So I hope आपको ये चीजें समझ में आ गई हों और आपको ये इक्वेशन याद रखना है और इससे आपको ये कंक्लूड कर सकते हो कि why it is called negative head. Okay, now last thing. Now if anyone asks you like what is the efficiency of the draft tube, so efficiency of draft tube is defined as net gain in pressure head upon velocity head at inlet of draft tube. ठीक है, वेलोसिटी हेड एट इनलेट ऑफ ड्राफ्ट ट्यूब क्या होगा? वेलोसिटी हेड क्या होगा? V2 स्क्वायर बाई 2G, बर्नौलीज थ्योरम, V2 स्क्वायर बाई 2G. और नेट गेन इन प्रेशर हेड में आपको लिखना है इट इज द दिस वैल्यू, sorry, it is this whole value because this whole. Now I'll explain you why or how it determines why it reflects efficiency. I'll tell you, don't worry. So V2 square minus V3 square upon 2G minus HF. Okay, so if you find this ratio, it will give you the value of efficiency of draft tube. Now see, it's like 1 minute, don't worry, we'll discuss. Now why it relates to efficiency? Because see, this is something which is constant, it will never change. And once you install the draft tube, this is also because see, the height of draft tube will never change कि कभी draft tube अंदर घुस गया कभी बाहर आ गया, ऐसा नहीं होगा. So anyways this will always be same. So जब भी if the water enters here, these are the factors that will be varying. V3 it will vary, the amount of friction, the amount of frictional loss, that will vary. So that's why this entity denotes your efficiency, because this anyways will always be constant, and once you install a draft tube, this will never change. Okay, so that's why your efficiency is V2 square minus V3 square upon 2G minus HF upon velocity head at the inlet, which is V2 square by 2G. Okay, you might be little bit confused about velocity head and this that. For that you need to please go and read fluid mechanics again, or at least refer to Bernoulli's equation, that sir what is head, what is pressure head, what is velocity head. So once you know all these concepts, it will be very easy for you to understand. Okay, so I hope in today's class you have learned, first of all, in today's class you have to learn two very important things. The first thing is this, the first thing will be the value. You have to remember this expression because this will be important from your examination point of view. And second thing is the concept, the fundamental, ki why draft tube is known to produce negative head, why they call that it produces a negative head. So you can justify it by this expression. Okay, so let's call it off for the class. I hope you all are doing great. Please take care of yourself. Okay, enjoy at your home, but please keep on studying as well. ठीक है, धन्यवाद.